Okay. So today is March 18th. And so yeah, your test, so your assignment threes are currently being marked. Your test twos will be marked. They will start the marking as soon as they're done assignment three. So with any luck, that would be this week. But I would not expect your assignment two back or test two backs until sometime this week, or the next week, the week that I'm indicating on the calendar. Assignment four is out. No more X11, at least for this semester. I was trying to, so there's specific technical topics that we want to cover, and I was trying to like wedge them into the X11 stuff, but I don't know. I ran out of time. I was too busy dealing with test two. So no X11 for that. There are some suggestions if you want to sort of dress up what you already have a little more, and put it up on your GitHub or whatever. And there's some suggestions in the assignment, but of course you can do whatever you like. All right, so that's where we stand. There's a tutorial 8 due this weekend. It has to do with actually some of the stuff we're covering right today, as soon as I'm done this. And I believe, so operator overloading with polymorphism and virtual inheritance, I believe, is the focus of tutorial 8. But yeah, so that's any questions? All right. We left off talking about operator overloading, which is, sort of a C++ specific thing. So, there's an argument to be made. It's not really software engineering in general, and that's accurate. But it is good for, C++ and C. The primary difference is between those and regular, let's say regular languages, is their emphasis on micromanaging the memory. Well, the reason why those two languages are still so popular is because they basically expose the hardware, right? So they behave a lot very similarly to how your CPU and memory behave. And so what operator overloading does is it gives us a chance to, I guess, look at those fine details again. And even if you never use C and C++ again, if you remember some of these lessons, right? So a lot of your languages like Java and Python are at least partially built on a platform of C and C++. So, when something happens that's unexpected and you're trying to figure out why it behaves the way it does, these models will come in handy. Anyway, so last class we were talking about operator overloading, and we were talking about specifically the stream insertion operator. And we were talking about, so in a straightforward manner, if I just have a class and I want to send it to the standard output, I can use the stream insertion operator, and that works fine. The problem happens when we have an inheritance hierarchy, and we want to, generally speaking, we want polymorphism, right? So if we just use the print, then we get polymorphism, right? So animal print will, if it's a chicken underlying that animal, then I'll get the chicken print. If it's a bird underlying that animal, I'll get the bird print. But now I have this operator. And so what we're doing here is we're taking animal pointers, pointing them at a bird and at a chicken, and then I'm trying to print those things out using the standard output. Of course, I just have this overloaded for bird. Let's change that to animal. Now everything should work. There is one drawback, well, almost everything. We need to make that a friend. That is, what is this, an animal? Okay. So now we have one single global function for this overloaded operator that takes an animal. The problem is, of course, now I only have this one behavior I can exhibit, right? So let's, yeah, and I forgot the return type, of course, as I always do. What else did I do? Undefined reference to bird. Yes. I no longer need it here. I have it in the animal class. Okay. P6. And then so down here, I print bird and chicken, but using their regular handles. Yeah, and what happens is that, well, this goes looking for a function to run, and the function that it finds is this one. And it says, well, is a bird an animal? And the answer is yes. So it's going to send it in and treat it like an animal. And then run this little animal code. So every time we print any sort of animal now, we just get this one type of print statement. So the question is, how do we get this diverse behavior? And the answer is, well, global functions cannot be made polymorphic, right? Because they're not associated with any class. However, my member functions are polymorphic. So if I call a member function in here, that'll basically solve the problem. So what I'm going to do is I'm going to say, well, now my print function should print to, I'm going to give it an O stream, some output stream that it should print to. And then it's a virtual function. And so if I call print, and I'll change C out here to the output stream that I pass in. So then, if I call print, I can call print on standard output, or I can call print on a file stream or whatever. The point is that now I have a polymorphic function that takes an output stream as an argument, and I can call it from in here. I can say, well, my animal's called B, but just call print on whatever type of animal this happens to be, pass in that output stream, and now this is a virtual function. So I can't get a virtual function from my global function, but I can just redirect it to a member function that is virtual. And then I get polymorphism. Even though it's an animal, I get birds that chirp like a bird, and I get chickens that cluck like a chicken, and all the types of polymorphic behavior that I like. And so yeah, questions? All right, and that's where on your assignment, you have to do something similar to that. I believe for the search classes, you have to be able to print them out so that I send my search class, my general search class to the standard output, and it finds the right function to call and prints it out appropriately. Okay. So we have touched on cascading a little bit. We're going to look at two more operators and see sort of the difference here. So one of them, right, so our general rule is operators should behave the same way that they do for integers. And so what that means is that, well, I should be able to, of course, run a piece of code that looks like this, which is I have a variable C that's an int, a variable A that's an int. I'm going to add A to C, and then I'm going to return something. And whatever is returned is going to be assigned to D. And for an int, it would return the variable C, right? So that's what I want to do. I want to return the variable. Technically, I could also return a value here, and that would work. But a variable is like a value, but it has more use cases, so we prefer to return that. And also, I want to see, well, what happens when I overload this function, or this operator. I have A and B added together, and this is going to return some value that gets assigned to C. But in this case, neither A nor B should be changed, right? So I want to return a value if A equals 3 and B equals 4. Then I want to return 7, but I still want to have that A is equal to 3 and B is equal to 4. So C gets the value 7, but A and B don't change. Okay, so let's do that. For an int, that's sort of straightforward, but let's do that for our time class. And, oh, spoiler alert. See, I forget. Some of these I forget, but okay, so we got all kinds of problems. So we're going to start. We're going to make a lunchtime object and print it out to the standard output. And there we go. We're in the constructor. That's going to come in handy later. You should ignore that for now. But lunchtime, 12 noon, perfect. Now I want to do something like this. I want to say, well, add, and let's call this 80 seconds to my lunchtime, and then print out lunch again. So let's figure out how to do that. And then also, I also want to call it down here. I want to be able to add another 20 seconds. But this should, of course, return something that I can print, right? So this should return, and what I want printed, well, not an integer, but a time object. So this should return a time object. And specifically, what we're going to return is the lunchtime object, right? So we're going to use a rule of thumb here. And the rule of thumb is if I have to return something of the type of the object that I'm currently using, then I generally want to do it by reference unless I have a good reason not to. Okay, so I'm going to return this by reference. This will take a second time object that I do not need changed, so I'm going to make it const. And all right, so there we go. That's our plus equals operator. Why are you not happy? Oh, sorry. This is for an int. Yeah, I could make it for another time object, but I'm supposed to be making it for an integer. All right. Then we go back here, and yeah, now the compiler's happy. It says it knows that there's exists a function that matches this signature, which we will now write. And int t. And quite simple, well, I added an extra function here. So I have my regular convert to seconds, which just takes the hours, minutes, and seconds, and converts them all into seconds and adds them together. So this is the number of seconds since midnight. And then I have a set time that basically does the opposite. It takes a number in seconds, and it changes my time into a number of hours and minutes and seconds that are equivalent. So we're going to use that. Here, I'm going to say int temp equals convert to seconds. And then I want to add t. And then if I was being, a good programmer, I would also check to make sure that this did not exceed some maximum, right? Basically 24 hours in seconds, whatever that happens to be. If it was above that, then I would change this to, I would do some modular arithmetic here. But I'm not going to bother. We'll just assume that everything works. And then I'm going to say set time to the temp. And that changes this to the new time. And now I want to return, well, in my code, I say lunch plus equals 80, and then I say lunch plus equals 20 here, and I really want to print out my lunch after I've added the 20 seconds, so I'm going to return it. And that would be this parameter, dereferenced, of course, right? So we need a time object, and there we go. Okay, so now we should be able to run this and see the output. So lunch before, and then I add 80 seconds, and I get 12:01 and 20. That's 80 seconds. That's great. And then I add another 20 seconds, and I get 12:01:40. And then I print it again just to make sure that nothing has gone wrong. And it's still the same, 12:01:40. So it looks like this plus equals function operator works. Questions? Okay. Well, good. Let's ignore all that then. And start over. We're going to make this I go home and you go home time. So I go home at 13:15 and you go home at whatever is the default time, which just happens to be midnight. Okay, and now what I want to do is I am going to overload at least one operator here. Maybe two might be a good idea, this assignment operator, but I'm going to stick with the default assignment operator for now. The reason why I can stick with the default assignment operator is because there is no dynamic memory in here. These are all statically allocated, which means that the default assignment operator is going to do a shallow copy, but that's all we need, right? So default will work. We'll write it later just for completeness, but we don't have to in this case. But what we need is this plus function. And so I want to be able to add to my time object some value. In this case, this is 3,600 seconds, which is 1 hour, right? It's 60 seconds to a minute, and then 60 minutes to an hour. 60 times 60 is 3,600. So, all right, well, let's write that function. So we're going to go with our, we'll try return by reference and see what happens there. Right, when in doubt, return by reference. Steal some code. It's simply a plus now. Okay, so I want to do most of these things, right? I want the current time in seconds. So I'm going to call this convert to seconds, and I want to add t to it, and then I want to set, well, I don't want to set the current thing to this time. So what I need to do is this plus operator should not affect the current time. But I want to return a time that represents the current time plus 3,600 seconds. So I'm going to make a new time object. Time, and then I'll say time.setTime to temp, right? So now this temporary time object is set to this time. Sorry, this is maybe a little bit pedantic, but let me, I want to swap these around, these values. I'm sorry, the names of the variables. So now the time that we want is the current time plus the time that I pass in, and then I make this temporary time object. I set the temporary time object to the time that I want returned, and then I'm going to return it. So return temp. All right. Anybody see any problems that can happen here? All right, well, let's try it out. So our compiler is happy with the syntax, at least. The syntax looks good, so let's try and run it. Oh, it's giving me a warning. The warning is a reference to local variable temp returned. Well, that's a very apt warning, but sometimes in C++ it gives you a warning and it's like, well, I don't care. It'll be fine. So let's try running it. And whoop, seg fault. So this warning actually is telling us something useful. And what it's telling us the following. So if I look at, somebody have a return by reference. Yes, that is what's killing us here. Is I have, well, imagine this is my function call stack. I called main. And then in main, I called this operator plus function. It's a member function, but it's fine. It still goes on the function call stack. And then in this, I make a temporary time object called temp. And then I return it to main, right? I return it, and then I try to assign it to another time object. Okay, so I'm returning by reference. And so this has some sort of memory address, right? So let's say that it's AA, that's a hexadecimal, very small number, but let's say that that's the address. So when I return this by reference, I'm really kind of behind the scenes returning a pointer. So I'm returning the memory address to main, right? So now when it wants to access this temporary time object, it's going to just follow this address. However, when I return from this operator function, of course, this gets popped off the function call stack, but more importantly, the destructor is called on that, right? So now I'm referencing a piece of memory that I no longer have access to. It's an old expired stack frame, all right? So we need to, what's new? Well, that would be one possibility, right? Yeah, you can put new and put it on the heap, and then you have to manage the memory, but that's okay as long as you're a responsible programmer. So yeah, the suggestion was, well, instead of making my time object here, I'm just going to make a pointer to a time object, and I'm going to put my time object on the heap where I decide when the destructor is called. And then I pass back this memory address, which is fine because it's actually this memory address now. That's the suggestion. So we're going to do something a little bit different here, though. That's a good suggestion, but it does mean an extra step in that I have to manage the memory. I have to statically allocate this stuff. What I'm going to do is I'm going to return this temp by value. And what happens when I return by value, now this doesn't actually happen, but in the model, what happens is that, well, we make a copy of this down in the previous function call stack. So when I return, I copy these values down here, and then I can assign them to some other time object. And then this old thing gets destroyed, but that's okay because we have a copy down here. Now what actually happens is the compiler does some weird optimizations where it takes some shortcuts, right? But that's, in terms of your understanding of what happens, return by value makes a copy in the old context. Okay, so that is the solution. And that applies more generally as well, in the sense that if I ever make a statically allocated object in a function and I want to return it, I should return by value. Right, so instead of returning by reference, which is, we saw that the compiler warned us that this was going to happen, return by value, and then it makes a copy. And like I said, it doesn't really make a copy because the compiler recognizes that, hey, you're just returning this, and so it has some optimization it can do. But in particular, the code works now. No seg faults, right? So yeah. So when in doubt, return by reference. However, if you're making a temporary object and returning that, then you want to return by value. Right? Questions? That holds not just for operators, but any functions. Okay, so this now works. All right, wonderful. Well, I'm not going to do it, but I could overload this operator if I wanted to add these two things like this should return the same thing, right? I should be able to add, well, now my left-hand side operand is an int, and my right-hand side operand is a time object, which means I cannot make this a member function. So I would make it a global function and make it a friend to my time class, and basically do the same operation that the plus function does. I'm not going to do that, though. This should also work, right? So, well, yeah. I should also overload this operator to add two time objects. I'm not going to do that either. Hopefully, you understand all of that. But just to be sure, any questions? All right, I'm going to show you another thing. A lot of people hate C++. And after seeing some of the stuff that happens, I get it. Here, oh yeah, I have, let me make a change here. I like C++. I think most of it makes sense. And I think in any language, you're going to get bits and pieces that are just, well, somebody made a decision at some point and then everybody has to live with it. And you just wonder why, how you ever got there. And this is one of those things. So here I'm saying you go home equals 60, which seems like, a pretty natural thing to do. I want to assign, I can represent a time as an integer value. And so here I'm going to represent this time, whatever, 3,600 seconds is 1 hour. So this should give me 1 o'clock, right? The weird thing that you may notice is that I didn't actually write an assignment operator for this. So somehow, and you can see here, it's actually, it's giving me the wrong operator. So this is, well, it's not actually. I'll tell you what's actually happening. So this is the operator that it's using. It's using the default assignment constructor. And yeah, well, that's interesting. So I actually, anyway, let's run it. So I didn't write an assignment operator. I get an assignment operator for free, but it certainly doesn't take an int. It takes another time object. So you go home after midnight. It says, oh, you go home is equal to 80. Let's do a couple things here. Let's just, so initially you go home is equal to 3,600, and then you go home equals 80. And well, in both cases, this is 0. And we got 2 constructor calls, though, when we did that. So what is happening? Well, this is one of those things where C++ can be a little too helpful sometimes. So it goes and it says, well, I need to find an operator that assigns an int to a time object. And I can't find one, but I can find one that assigns a time object to a time object. And then it says, well, can I convert this into a time object? And the answer is yes, right? It can construct a time object given that argument. It takes 3 integers, but they all have default values. So I can give it 1 integer, and it'll just go into this parameter. And so I'm basically making a time object that says 3,600 hours. And of course, when I go to set the time, it says, well, 3,600 is too big, so we'll just set it to 0. Okay, and we can sort of verify that by saying, well, instead of 3,600, we can make it like 6 or some valid time. And then we get 6 p.m. And so, yeah. And this is really kind of nefarious, because this is not what I would expect to have happen, right? So we're doing this implicit conversion from an int to a time object. Really, I wanted this to be something that I wrote. Of course, we've seen this sort of behavior before when we looked at copy constructors. And we said that, well, if we want to get rid of implicit conversions where the compiler just figures out some constructor to call in some situation to convert from one value to another, I can say, well, only explicit conversions, and then we get an error, which is good, because now we can just write the operator, and that would be pretty straightforward. Actually, let's just do this. Steal this piece of code. Return by reference when in doubt. That works for me. Equals, and then it's, well, it's real easy. I'm just going to set this to t and return it. And that should, so now I can assign this as 6 seconds after midnight, and here is 80 seconds after midnight. And this should all work now. So yeah, 6 seconds after midnight and 80 seconds after midnight, 120. So the takeaway from this is, well, first of all, be careful, because C++ will try and convert things, and that can cause weird, unexpected behavior. But the main thing is that if I'm making a temporary time object, I need to, and I want to return it, I should return by value. If I'm not making a temporary time object, if I'm, for instance, just returning this time object, then I can return by reference. And that's a pretty good rule of thumb. And this is more than a rule of thumb. This is an error unless you do it correctly. All right, questions? Sweet, 904. All right, and this basically talks about all the things I just talked about. Oh, collections. I forgot about this. All right, let's do some operators on collection classes. So the main lesson here is going to be, well, what sort of things should we consider when doing operators on collections? And, what is a collection? Well, collection is just, we've made a bunch of them. In this case, we're going to make an array of books. array of book objects. I made that way too small. But we know arrays are finicky and dangerous. So I'm going to make an array of book objects, right? And this is going to, of course, call the default constructor on each of these locations. So those will always be populated with books, and then I'm going to access them. And so if this is called ARR, then I want to be able to say, you know, which book is at location 1. Of course, the danger is if I say ARR 3 is okay, 4 is not. Right, so technically these are the locations. So location 4 is some unknown memory address with unknown memory, and I can, basically with a regular array, I can manipulate that. And maybe I get a seg fault, or maybe not. Maybe I corrupt one of my other variables and do something really horrific. So I want to put a light wrapper around this array. And by wrapper, I mean I'm just going to put it in a class. And that class is going to do bounds checking when I do this subscript operator, right? So I make a little class that wraps around this book array. I only have space here, but so it's going to be a book array class. And to start with, I am going to, actually for this example, I'm going to statically allocate this book array. So this will be stored inside my book array object. Okay, so that's what the memory is going to look like. And then I'm going to have some functions. Okay, so let's take a look at that. So we have our book class. We've overloaded this stream insertion operator, and then we got some other stuff. We have an ID that automatically increments, so that's great. And we have some getters, but otherwise it doesn't do much. It just prints out some book information. So I'm going to make a bunch of books, and then let's start by just printing out a couple just to make sure that this is working okay. Error. Did I leave something here? Array 28. For some reason left this in here. All right, let's get rid of that. We haven't even gotten to the book array yet, so it's just did I not save it? Okay. All right, so there's 2 of our books, Ender's Game and Dune. Fantastic. Okay, so now we want to make a book array that's going to contain them. And here's the constructor. I'm going to change it a little bit because while this version does demonstrate some things, I want to demonstrate slightly different things. So I'm going to change it from, well, here I have a pointer. And so I was going to dynamically allocate an array of books onto the heap, but instead I'm going to statically allocate it. And I'm going to declare this as a preprocessor constant, capacity of 4. And then when I declare this, I want a statically allocated array of size 4. Okay, and then I don't need to explicitly store the capacity anymore. It's a preprocessor constant. And this is just going to change a few things so that we can create, a particular lesson. So now I pass in the capacity, but I'm just going to ignore that. And I'm going to ignore this. So technically, I don't really even need a constructor and a destructor. I have a print, which is just going to go through all of the books and print them. Okay. So now I made a book array, and I want to assign some of my books to that book array. And you can see here, of course, the compiler Well, you can't do that because there is no function that will do that. So we're going to write that function. And so, yeah. Well, what do we want to do when we assign this book, B1 to this array position? What's happening in memory is the following. I have, what is this, Dune or something? I have the book Dune, maybe on my call stack, and I have my book array here with a bunch of default books, default values. When I call the subscript, it's going to return a reference to this first book. So it's, behind the scenes, it's going to be a memory location. And then I'm going to say, well, assign Dune to this book, right? So I'm going to copy the contents of Dune into this memory location. And then, so in my array, I'll have a copy of Dune. And then I'm going to do that for 4 other books as well. So what I want to return here is, when I use the subscript operator, I want to return a reference to that location in my array. Okay, so let's do that. I want to return a book. When in doubt, I'll return it by reference. This is the subscript operator. It takes an integer as an argument, right? So this is the location. And then I can say book array. And now, so I'm going to overload this operator. I really just want to kind of forward this to my backing array, but I'm going to check the index first. So if index is not valid, so if index is less than 0, or index is greater than or equal to the capacity, then, well, I mean, I don't have many options here. I'm returning a book by reference. I shouldn't really return a null pointer. What I'm going to do is I'm going to fail loudly. We're just going to crash, right? Which is better than the alternative of like possibly corrupting some other part of your memory. So if you're out of bounds, we crash. Otherwise, I'm just going to return. Again, I just want to forward that call to the backing array. So I'm going to return the element at that index, which is a book object, and I'll return it by reference. All right, so great. These errors went away. Let's make sure that it works. We're going to print out those books, but now we're going to do it using the subscript operator. All right, so let's get rid of this line. So it should print out the same 2 books. And there we go, Ender's Game and Dune. Fantastic. All right, questions so far? All right. I didn't make this const. I mean, should I make it const? Not really clear right now. So let's try something else. Instead of printing out the individual books, let's say I wanted to do this. I'm going to send the entire array to the output stream, and I want that to work. So I'm going to overload the stream operator here. Well, we should know how to do that, or at least have a decent idea. And we are taking, what is this, a const book array by reference. Okay, so that's, we're a friend of this function. And let's go write it. And it's going to be very similar to this print function. In fact, I could use the trick of like just calling the print function, but let's try something slightly different. I'm going to need a loop. I want to loop over all the elements. And well, capacity it recognizes, elements it does not, because, well, I'm passing in explicitly this book array. And this will work because book array is a friend of this function. So I can access the private elements here. And there's nothing wrong with doing it this way, but let's try it a little bit differently. I did write this operator. So instead of calling elements, I could just say, well, just grab the ith thing from that book array. And we'll notice that the compiler doesn't like it. It says no operator matches these operands. Even though I just wrote that function, it says this is no good. So why is it no good? Why can I not call this function? I mean, there's the output as well. So what happened? I knew someone. It is not a friend. Well, it is a friend, right? Book array is a friend. This function, there's something else wrong here. I'll give you a hint. It's this const here. My book array is a const book array, right? And that's, generally speaking, I should make it const if I don't need to make it non-const. This is causing a problem here. I could just take away this. It'll get rid of that particular error, but that's maybe not the most optimal. Let's try and make this function const. Okay, and then I go back here and, oh, that solves that problem, right? I can call a const function on a const object. This is causing me problems now. Oh yeah, well, because the signatures don't match. Oh, return elements. Well, what is happening here? Well, I put const, and this const is a promise that I'm not changing anything inside this book array. And yet I'm returning a reference to part of the book array, right? This part is inside my object. So I'm returning a reference to location 0 here, which means that whoever gets that reference can actually do things like copy Dune into it. So it can make changes to this object. And I specifically said I'm not allowing that in this function. So what's the solution? Well, one solution is return by value. But let's try this, const. Return by value has other problems. I'll let you think about that and figure out why we would not prefer to do that. But let's make everything const. Okay, this problem goes away. This problem has gone away. So printing is fine. Oops, this does not work anymore. Also, I messed up this. Right, because I'm returning by reference and trying to copy things into it, but these are const objects now, so I cannot copy these things into it. So I seem to be at an impasse where I need const version of this function and a non-const version of this function. So the solution is, well, I'll just make both, right? That is, in C++, we are allowed to overload a function with a const and non-const version. And what happens is that by default, it'll try and call this one. And if this one doesn't work, it'll call this one. Anywhere that I can get away with this one, it'll use it. And where I need this one, it'll use that there. And so if I look now, it seems like, I guess I have to write this. I have to write this, but it will be exactly the same thing. That problem goes away, that problem goes away, and I should be able to, yeah. That never goes away is me forgetting to return the output stream. And it used to work, the compiler used to be nice and just return it for me if I forgot. But now the compiler, somebody changed the compiler and made it throw an error every time. So yeah, when I print out the array using the stream operator, everything works. All the books got assigned to the array correctly. And yeah, so the main idea here is that in this case, for the subscript operator, this is a pretty good rule of thumb. You probably want to make a const version and a non-const version if you're using this operator. And if you use something from the standard template library, like a vector or a list, those will do this, right? They have overloaded versions of the subscript operator. Vector does, sorry, list does not have subscript operator. So they do exactly this, and for precisely this situation. Okay, questions? All right, the other thing we want to write, well, that is, maybe we also want to do stuff like this. So I'm going to make a second book array, and then I'm going to print it out, and you'll see we get all default values. I'm going to assign book array 1 to it, right? So I want to copy book array 1 into book array 2 and then print it out again. And you'll see, because we do not have any dynamic memory, that works just fine. So array 2 initially, it has all just default values. Array 1 just using this default assignment operator. But just for fun, let's write it ourselves because, well, you may need to at some point. And just to get a look at, well, what sort of things should we consider? Well, we want to enable cascading. We're going to return the current object when in doubt, return by reference. I want another book array passed in. And yeah, let's write this. Not because we have to, but because we're just going to talk about the things you should consider if you do this. And when would we actually need to do this? Well, you would, not in this case, right? Because everything is statically allocated, but did it make a deep copy? It made a shallow copy, right? But that's actually all we needed. So there is nothing deep. So when I say deep copy, what am I talking about? I'm saying that, well, something inside my book array object points to some value on the heap. But that's not the case here. I don't have anything on the heap. Everything is inside my book array. So a shallow copy works just fine. So what we're writing is a shallow copy. You would want to do this if, for example, we went back and I said, well, here I made the, I made it statically allocated, but I could make it dynamically allocated pretty easily. In fact, let's do that just for fun. I don't think this won't even take any time whatsoever. I'm going to use capacity here, even though, so this is, typically I would be using this in there. So now I have dynamic memory. Everything else is going to work just fine. Let me see here. It's not going to like that I did that, is it? Okay. Well, let's write this then. Let's think about the things that we should consider. Int cap. Call this cap. So we're going to keep track of the capacity. Instead of this, actually, let's just call this capacity, and then we don't have to change anything, and then go up here and comment that out. And then all of our code will still work magically. So capacity equals cap. So now we're passing in the capacity explicitly. And then we're making a new array of books. So we've changed our model from here to here. So this no longer looks like this. Now I have a book pointer. And I have a book array on the heap. And each of these has a book in it. And our picture looks like this now. And if I do use the regular assignment operator and make a second book array, well, it does a shallow copy. And what does that mean? Well, I'm just going to copy this pointer address. And so I'm going to have a pointer that points to the same piece of memory. And that's not what I want. So So yeah, we'll do it this way now. Now we have dynamic memory, so now we really actually should write this assignment operator. And sorry, did I lose anybody, or is there any questions? Okay. So now we really should write this operator, and the tell is that I have a new here. I have dynamic memory inside my book array, which means that I probably want a copy constructor as well, right? So the rule of three, I should have a copy constructor, I should have a destructor, and I should have an assignment operator. This BA dot capacity. Okay. All right, so what should we check? We should check, well, first of all, are these two things the same size? So I want to make a copy of this book array into my current book array. So I'll say if BA dot capacity is equal to my own capacity, right? This is implicitly saying this capacity. Actually, I don't care if they're the same size. If they're the same size, that's good. If they're the different size, then, well, if I look at my diagram, so I have, when I made this book array, it was already pointing to something. And if these are the same size, then I can just reuse this, right? Because I'm going to be able to fit the 4 books into these 4 books. If they're a different size, however, if this was only like 2 books, then I have to delete this and make a new one of the correct size. So that's what we're going to do. And then once we've done that, then we can copy these books over. Okay, so let's... So if the capacities are not the same, well, I'm going to delete actually my current, what's it called, elements. And this is actually an array, so I should do it like this. And then I'm going to say, yeah, and then we'll say capacity equals the capacity from the book array that we're copying, and then we'll say elements equals new book capacity. Okay, so everything we just did in that diagram, we just did here in code. Now we know that we have the correct size backing array, and then so we're just going to run a for loop. We're going to steal this for loop. Since BA dot capacity is fine, or I could just use my current capacity. And then elements equals BA at I. And yeah, that should do it. So if the capacity is different, then I have a bunch of background work. If the capacities are the same, then I just copy the elements. And that should copy array 1 into array 2 and then print out array 2. Not going to let me get away with that either. Of course, I want to return this. Okay, so array 2 originally has a bunch of default values, and then when I copy array 1 into it, I get this. And also, if I ran it with Valgrind, no problems whatsoever. So each of them has managed their own memory. I've copied, I made deep copies where I had to, and I've deleted everything in the destructor. All right, questions? Okay, there are a couple of other that I think we're going to skip. But right, I could write double equals. And we'll just talk about what you would have to do in that case. So I want to see, is this book array here equal to this book array? And what I'm going to do is I'm just going to say, well, they're the same, right? So now how do I define that these two things are the same? It really depends on my collection class. In this case, if I have a different capacity, then they're different, right? Because there's no way that all the books match up. If they have the same capacity, then what I want to do is I want to say, well, is book 1 here equal to, or sorry, book 0 here equal to book 0 over here? And if that's true, then I'll say, well, is book 1 here the same as book 1 here? So I'm going to go through and I'm going to compare each individual book. And if I find any of them that are not equivalent, right? So let's say book 3, I say, is book 3 here equal to this book 3, or this book 2, sorry. And if the answer is no, then I return false, right? So all I need is one book that is different to return false. If they are all the same, if I get through the entire loop and I never encounter two books that don't match up, then I can return true. These are equal. I'm not going to do that because we are falling a little bit behind, but questions? Okay, I am going to go pretty fast through this next one. Yeah, that's the deep copy. So the increment and decrement operators. All right, there's lots of variation here, so I'm just going to throw a bunch of stuff at you. If you get lost or confused, please ask questions. But I have, right, so I can say plus plus I or I plus plus, and both of those things increment I. They do it a little bit differently, though. And then I also have minus minus I or I minus minus, and the same deal. They decrement it, though. And so prefix and postfix behave a little bit differently. And we're going to overload these. We can overload them as global or member functions. Usually you would do member function we're going to do both just to show you how it works. And of course, our rule of thumb is it should behave the same as an int. So we're going to have an int as well to kind of show how these things should work. So we're going to start with an int and a time object. All right, so the original int is 10, the original time is 12:28. So how does well, we're going to start with the prefix operator, right? So this is a prefix operator on the integer. And so what happens? Well, it happens what you would expect to have happen. 10 gets incremented, and then I return the value that's currently inside 10. Right? That's all that happens. So I increment it, it's 11, I return that value, and then when I print it out again, it's still 11. And this is what I want to have happen to my time object with this same function. So let's write that. We're going to start by writing this time. When in doubt, return this by reference. Plus plus, takes no arguments. Now, we don't want to make it const because we do definitely want to change it. Then what do we want to do? Let's just add 60 seconds, right? So I'm going to say int. Oh my God, can you please not put up a menu in front of my face every single time I want to do something? Convert to seconds. And then I'm going to add 60 seconds to that, right? So I'm going to convert the current time to seconds. I'm going to add 60, and then I'm going to set time to this temp. And then I want to return this. Okay. And all right, so no errors here, no errors here. Let's run it and make sure that we get the behavior that we want. And whoops. Well, we do want to run these two lines of code as well. And so there we have it. We increment the 10, the integer, we get 11, and then we print it again, we get 11. And then we do the same thing with our time object. It's incremented to 12:29, and then after we print it again, it's still 12:29. So good, that works. All right, let's do decrement. And the decrement's going to do the same thing. So if we test it with our int, we're going to use prefix decrement on 10. And indeed, it decrements it and then returns the current. And we wanted to do the same thing. Of course, this is, I'm not going to do it as a local function, though. I'm going to do it as a global function. Now, I typically would not do that. I would prefer that it's a local function, but just to show you how we would do it. We're doing friend. It is a friend. Of course, now down here, I implicitly pass in this as a parameter, right? So the current object exists in this function. No such thing up here. This is a global function, so I have to explicitly pass in the thing that I want changed, right? So we're going to pass in this time object. That is the time object we want changed. Otherwise, this is going to behave very similarly to what we have. And in fact, let's just copy this over and make the necessary changes. Well, we can see convert to seconds. Well, I want to take this time object and convert it to seconds. I should subtract 60. Again, it would be a good idea to make sure this is a valid number, but we're not going to worry about that. T.setTime, and then return T. Okay, so now this should work. Basically the same, but from a global function perspective. And indeed, it gets decremented to 1228, and then when we print it again, we get 1228. Perfect. All right, questions? Okay, let's do postfix. And what does postfix do? And yeah, sorry, I'm going to, well, let's see it. So I said 10 plus plus instead of plus plus 10. So when I said plus plus 10 up here, it went from 10 to 11, returned 11. When I did 10 plus plus, it went from 10 to 11, but returned 10. Right, so sort of what's happening at this says, well, increment 10 and then return the value 10. And what this is saying is return the value 10 and then increment it. But we can't actually do that, right? We can't actually return something before we finish the function. So what we're going to do is we're going to, well, we're going to make a temporary time object to store the old time, and we're going to return that, right? So we want to increment the current time object, but we want to return the time that it was previously. So we're going to make a temporary time object to do that. Okay, and of course, we're making a temporary time object and returning it. The rule is return by value. Okay, well, oh, now we have a problem. Cannot overload functions distinguished by return type alone. The compiler does not like this. Right, the compiler, these look exactly the same to the compiler because return type cannot differentiate it. Now, when it goes here and sees this syntax, of course, it recognizes what this function should be, and it can tell that it's different from this function because we wrote it differently. But here, not so much. So this is, we talked a little bit about implicit conversions, which are a big pain in C++. This is another one where it's just like Christine calls it the, I have 10 minutes to finish my homework. Here's a solution, which I think is pretty accurate. So what they do is they just say, well, here's an int. You don't need it, but it makes the signature different, right? So when I write this, the compiler says, oh, this is a postfix operation. The int, I don't actually even need it, but I can use it if I wanted to. So we want to do something similar. We want this dummy. Now, I don't have to use this, but I can use, I declare a local variable here. I can just use this dummy variable instead. It doesn't get any values that I know of. Maybe it starts as 0, maybe not. but we're going to use it because you can. So we're going to say temp equals convert to seconds plus 60, set to temp. And then we're going to return not this, but, well, actually, we don't even want to do that, right? We want to make a temporary time object. So we want to set the time to the temp, but before we do that, we want to make a copy. So time, copy, and we just want to make a copy of the current time, and we want to return that copy, right? Or maybe this old time. Old, old time. Okay, so this is going to be the current time. That's the current time in seconds. Before I set the time, I'm going to record the old time so I can return it. I'm returning a temporary time object, so I return by value. That should handle all of those cases. And so what do I want to see? Well, I see 1011 here, so I want to see 1228 and 1229 when I run this code. And there we go, 1228 and 1229. Question. No. All right, let's do the last one. Postfix minus minus. And we're just going to, again, just do it as a global function. We want to make a temporary time object and return it by value, and we have to tell the compiler that, hey, this is the postfix version by passing in this dummy variable. And then when we implement it, return by value. Again, I don't need to use it, but I'm going to use it anyway, just for fun. I'm going to take this, convert to seconds. I do want to change this, but before I do, I'm going to make a copy. Time, old time, t, then return old time. Okay, and then we can see it's at 11, and then so I did a postfix decrement, so it decremented it, but returned the old value, and then the new value is 10, and I get the same behavior. Time object, the old time was 1229, and the new time is 1228. And yeah, so that's, so here maybe you can get an idea of why, I mean, we don't really carry a big stick on it because the compiler is pretty good at optimizing it, but technically speaking, the postfix operation is slower, right? Because we make a copy and then we return that. Sorry. Exactly. So let's talk about the difference. So, right, so operationally, they are different, but when should we care? And so outside of a for loop or inside of a for loop? So when I write a for loop, you might see me write something like this, equals 0, I less than some value. I often do this reflexively, plus plus I, but when a lot of other people write it, they write I plus plus. And so you would think that I plus plus is a little bit slower, and so we shouldn't do it. But of course, compilers being the smart things that they are, this is sort of outside of any expression. And so whether I use I plus plus or plus plus I doesn't actually matter. And the compiler recognizes that. And so it compiles this into the same thing as this. And generally speaking, if I say, if I just wanted to increment this on a line by itself and I said I plus plus, well, that's the same thing. If I use plus plus I here or I plus plus, in terms of what happens, they're not different in this case, right? Because I just throw away the return value. So the compiler recognizes that. So if you write I plus plus, it actually substitutes plus plus I. Right, so the compiler's smart. It'll do that for you. So for your for loops, don't worry about it. And for just something outside of an expression, it doesn't matter. But of course, inside of an expression, right, where by that I mean something like this. This is now inside this other expression. So the return value of this is being used here. So if the return value is being used, then it matters. Right? Then you want to take care on which one you use. If the return value is not being used, then I plus plus, plus plus I, same thing. All right, questions? Okay. 10 minutes. Let's see, what do we have? We have something else? Oh, smart pointers. Goodness gracious, this is a long operators. We're almost done though. All right, we're going to do smart pointers. Maybe we'll skip reference counting or we won't get to it. But so you've, of course, you've used C++, which means you've had seg faults. So, and well, we use raw pointers to help you sort of think about memory, right? So to force you to think about it so that you actually do make these mistakes and then realize how did you make this mistake and why did you make this mistake? But when you use C++ in a workforce, you're probably going to be using things like smart pointers or reference counting pointers. Now, reference counting pointers are basically like Java. Once I run out of references pointing to some dynamic piece of memory, it gets deleted for me. The difference, there's a slight difference. Java uses a garbage collector. C++, it uses the destructors, but yeah, this is actually, anyway, not to get too distracted here. So what we were going to upload some operators and make a smart pointer. And then maybe talk about how to make a reference counting pointer, maybe make one. So to do that, we want to overload, well, actually not so much this one. I would have to think very carefully about whether you need that. I don't think that would come in handy, but maybe. But definitely this arrow operator and the dereference operator. So the goal is to make a class that acts like a pointer. So let's see what that means. We have our time class. Let's get rid of this. We have our print function that overloads, it takes this O stream because it's going to come in handy later. But basically, I'm just forwarding this operation to my print function. Nothing to worry about here. We're going to start by making a time object and printing it. Or not. Let's see here. Every once in a while, it just freezes for no reason. Let's do prompts. All right. So we're going to make a time object and print it, and the time object is 10, 10, 10. Cool. So now we're going to make a smart pointer, and I have a bunch of other code that we don't really need. And it's not a templated version, not yet. We'll do that later. So what we want is a smart pointer that just points to this time object, and then we want to be able to do pointer stuff with it, right? So we want to be able to say, like, smart pointer, print this time object to the output stream. Or maybe I want to do cout and then dereference the smart pointer and send it to the output stream that way. Right? We only have a print function, so I'm sort of relying on that for these examples. But this is what I would expect to work. And then when I'm done here, get rid of all this. When I'm done here, I would not have to delete this. This would be done automatically for me. All right, this is an example of resource acquisition is initialization, which is like 3 giant words that really just mean take every piece of dynamic memory and attach it to a piece of static memory so that that's going to delete it for us. Right, that's all that it means. Okay, so we want our smart pointer class to be initialized with a new time pointer. And then I want to be able to do pointer stuff with it. Yeah, that's fine. All right, so here's our smart pointer class. Well, we need a constructor that, this is this notation here will actually call the smart pointer constructor and give a time pointer to it. So let's take in a time pointer. And well, actually, I probably want to store that time pointer. So let's make a member variable time. And we'll initialize it with this time pointer. And that should be good. So that's member initializer syntax. So we've initialized this. Of course, the whole point of the smart pointer is that I should delete this thing. Right, so now I have, well, it manages the memory for me, and it also, if I look at this, this works now, and when the smart pointer gets deleted, the rest of it should get deleted. And I could test this right now with valgrind. When I got 4 minutes, should be enough. Right, I didn't explicitly delete the time object except in the smart pointer. So I should be able to call valgrind. And yeah, no memory leaks. So when this went out of scope, it in its destructor. But now we want to allow it to do some other stuff. So there's a rule of thumb for this this operator. And the rule of thumb, it's not even a rule of thumb, it's a rule enforced by the compiler. It must return either a pointer or something else that overloads this operator, right? So technically a pointer overloads this operator, so technically return something that overloads the operator. And then eventually it gets down to, I return a type that has this, and then the compiler calls that function again. I return another type that has this, and the compiler calls that function again. And then eventually it gets a pointer, and then it follows this pointer and then does pointer stuff with it. So yeah, we have to return a pointer or something that overloaded that. Well, we'll go with pointer. We have a time pointer we're going to return. And this takes no arguments. I just want to return time. Easy peasy. And this should work now. And so we made a new time object. Let's print it. Yeah. And there, 10, 10, 10, which is, so that worked. Now we just want this to work. Let's do a little formatting. Okay. So this now, I dereference a pointer, I want to return an object. And in this case, I want to return a time object. And when in doubt, return by reference. Operator. Again, this takes no arguments. There is one implicit argument, the this argument. But now I want to return a time object. I want to return the time object pointed to by this pointer. So return, oops. And basically just forwarding this. Please stop doing that. My goodness. This autocomplete is a little over ear sometimes. So yeah, I'm just forwarding this operation now to the actual operation on the time pointer. And then I should be able to print it out using this. So it should print out twice. And there we have it, printed out twice. And of course we can valgrind it again, and no memory leaks. So I assign it to a smart pointer. I use the smart pointer as I would a regular pointer. I don't have to delete it, right? Memory is managed for me. All right, questions? Okay, maybe next pointers, but so now the problem is, well, I have this time object on the heap, and I have my smart pointer pointing to it. but maybe I have a second smart pointer that also points to it, right? This is pretty common. Maybe it's in more than one collection class or whatever. So I don't want to delete this. If this goes out of scope, I don't want to delete the time object. I want to delete it when the last one goes out of scope. So I want to have a way of counting the number of references. So we'll maybe touch on that next class. So yeah, that's it for today. I'll see you guys on Thursday. Yeah.